Jaden, let's go. I'm watching you go down the hall and get it. Okay, so today our agenda is to look at the transformational geometry review. We should wrap that up today, Jordan. You should have this. You've been here at least once over the last 3 or 4 days, and we've been working on it for a while.
You gave them a bag. I do that.
Then let's get it out. I just want to point out, it doesn't make any sense if we're doing a bell ringer that deals with stuff we've been working on in class, not to get that assignment out. Especially if we didn't finish it. We're probably going to finish it today. Is he not in there, Jaden? Well, come grab a seat, write your stuff down on a separate sheet of paper. Yeah. Say again. Okay. She should have them at home. I don't have them. I gave them to her.
Baby shower.
Okay, and then we can get into the textbook today. So, with the transformations, please remember these transformations are actually super important because if you translate, rotate, or reflect a polygon, what do you get as a result? There's a lot of things you could say here, but there's one key one. It's the same, so what do you mean by that? Okay, so the elements are preserved, but that means that the polygons are, okay, but what's the mathematical word for the same? They're congruent, right? So what things are always preserved? The area, side lengths, and the angle measures, right? All 3 of those are always preserved, right? Some of the other things are preserved as well, depending on what's happening. We'll talk about that in a second when we wrap this up. But don't forget, we're creating those congruent polygons, all right, when we do those transformations. All right, 2 quick points of order. We're just going to go over this because I asked y'all to do this last night. But what I was actually going to say is this. Ladies and gentlemen, please hear me very clearly on this. I know that some of us are at the point where we don't actually believe it when I greet you and you respond with, "I'm capable." And some of us respond, but then we come inside and we don't do the things we need to do. Guys, I need you to hear me very clearly on this. You are fully capable of learning. I'm not saying that everyone's going to make 100 or everyone's going to make an A in my class. When you respond that you are capable, it means that you are capable of growing. Whether that means you are capable of growing mathematically and learning this content, or capable of growing socially and talking with people and learning how to collaborate with people, or whatever, you are capable of growing. And I cannot emphasize that enough, because when you come in and you sit down and you do nothing, are you going to grow and learn? No. If you put 0 in, you're going to get 0 out, and you're just going to get more frustrated. I'm always going to work with everyone, but I cannot do the work for you. You are, in fact, capable. I don't care who you are. You're capable of growing in every facet of your life. But if you don't try, you will not succeed. I cannot emphasize that enough. So if you're sitting there and you're like, well, Mr. Kinney, I just can't talk with people well. Start talking with people. Practice it. I'm not saying it's going to become great overnight, because I know that I still struggled after years in communication with people, and I'm still getting better at it. What I'm saying is you're capable of growing and learning. If you're struggling with the math, that's okay, but if you put in some work and effort and do what I ask you to do, then you're going to improve. The reason I have those active collaboration scores is because the foundations of being successful is actively collaborating and engaging in the math. At the end of the day, if you are taking notes and you're actively talking in the class, you'll get your questions answered so you can do better at these things. You are all capable of growing and learning, and I need you to operate that way. Yes, sir. Oh, this must be the rest of the stuff I ordered. Thank you. Forgot that I ordered other stuff. All right, I'll do this later. But let's get started on this. Let's look at this number 10 here. So we rotated triangle XYZ. And I think Nathan brought up already when he walked in, he was like, Mr. Kinney, I'm struggling with the rotations on Khan Academy, right? If you go on to the rotations on Khan Academy, you should note, hopefully, that all of the rotations, I think, are by what interval? Or they're always what angles? I believe they're all 90-degree rotations, right? So you don't need a protractor to measure those 90-degree rotations. Do not forget that when you rotate it 90 degrees, like right now, this point is 6, 2. If I'm going to rotate it 90 degrees, what do I immediately know about those coordinates? They're going to switch every time. Your x and y switch every time. And so I know that we said we're going to do clockwise, correct?
Yes, sir.
So instead of being 6, 2, I'm going to look at a 2 horizontally and a 6 vertically. Okay? I know that those are going to switch. Why? Why do I know that they have to switch like that? Yeah, but there's another reason why. Someone was saying something over here. So that's part of it. Say again. Are we translating in this one? Yeah, we're rotating. Okay, so if you didn't already remember this, you should get your head up, and this should already be in our initial exploration notes, which I noticed we don't have out. It would be useful, right? This is the review packet based on what we explored on the calculators. What, if we're rotating 90 degrees, what should that immediately make us think about? Opposites and reciprocals, right? Those right angles. Notice if I draw a line segment to here, what's the slope of that line segment? It's rising 2 and running to the right 6 for a slope of 1/3, right? But if I rotate 90 degrees, what should be true about these line segments? Yeah, they should be congruent, but there's something else. The slopes are opposite and reciprocal. If it's rotated 90 degrees, I should be creating a right angle, meaning that those segments are perpendicular, right? So to get this right angle, notice I had to go to the right 2 and down 6. This is 2, -6. Notice the slope now would be down 6 and to the right 2 for a slope of -3. So in order to get that 90-degree rotation, the x and the y are always going to have to switch. And then just pay attention to the quadrant, right? And that's what Emily was referring to earlier. To get into this quadrant, the x is going to the right, and the y is going down. That's why it's a +2 and a -6. So if I do a 90-degree rotation, the x and the y are going to switch, and I figure out if the values are positive or negative based on the quadrant that it's in. Does that make sense? Okay. So this point right here, the pre-image was z, so this would be z prime. That's x. Remember that was 4, 5, so it switched and became 5 and then down 4. That's x prime. Y was -1, 3. So the x and the y switched, so I'm going to the right 3. I think it was up 1, wasn't it? Because it needs to be in this quadrant. And so this would be y prime. And there is my rotated triangle. Okay? And this is all about what we just discussed, the slope of xy. So if I look at x to y, we should have gotten a slope of, I believe, 2/5. And if we look at the slope of x prime, y prime, we're looking at -5/2. Slope of yz is -1/7. The slope of y prime z prime is 7, or 7 divided by 1. Xz was -3 divided by 2. And then 2/3 here. Now, I'll point this out. I usually don't move that fast. I usually let y'all work through it a little bit. But you were supposed to do that last time.
Where we were?
Yep.
Today, Tuesday, right?
How come
That's okay. So if you did do it, I will address that. If you did do it, are there any of these that we need to talk about? Because we got them wrong.
I didn't place my points correctly.
That would affect it, right? But when you do place those points, right,
It does make sense.
it makes more sense, okay? So, look at XY, line segment XY and line segment X prime, Y prime, are they parallel, perpendicular, or neither?
Perpendicular.
How do we know they're perpendicular?
Because
So be careful. I hear a lot of people, and a lot of people are saying this, it's perpendicular, or it's opposite and reciprocal. What is?
the angle X, Y, and X prime.
The line segment.
No, you're close. What about that line segment?
The angle.
You know what I'm saying? It's opposite and reciprocal. What is opposite and reciprocal? There we go, guys.
I told him that.
Those line segments are perpendicular, but the slopes are opposite and reciprocal. That's how we know they're perpendicular. We need to be careful with that language. And when you say it, notice when I started asking you, what do you mean by it? A lot of us weren't sure. If you're ever using the word it, you're being unclear, and you probably don't understand it as well as you thought you might. We need to be clear with our language. Don't use it. The slopes are opposite and reciprocal. So I'm going to put perpendicular symbol there. What about YZ and Y prime, Z prime? They're perpendicular. How do we know? The slopes are opposites and reciprocals. XZ and X prime, Z prime. They're perpendicular. Oh, I just realized we never went over the bell ringer, did we?
That I was about to say something.
Thank you. So sorry, that's my bad for just having a brain fart. But there's number 10. Okay, we'll do number 11 in a second. And the reason I did the bell ringer is to help with number 11. That's why I realized. All right. So let's look at it. So the point 3, 7 is rotated 180 degrees clockwise. So 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7 would be way up here, right? And so I got a couple of people who put the point here. Yeah, 1 there, 4 here, and then I've got only 3 there. What? 21 of us I thought responded. I don't know where everyone else's answers are. Oh, there we go. There's most of them. Okay. So, it looks like a lot of us did recognize, hey, we need to switch those X and, or maybe we didn't even switch X and Y. It looks like a lot of us just reflected. Let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Right here. How did we get this point? That's a what? That's a reflection over the y-axis. Is that supposed to be a reflection over the y-axis? No. I would also point, if you moved to right here or it went to right here, did the x and the y switch?
No.
No. Trent, are you paying attention? Are you paying attention? I'm pretty sure over the last couple of days I've multiple times had to say, hey, you paying attention? And you had to say, well, no. Okay. It's more than just twice though. Alright.
Is this still raining outside?
Jordan, how is that going to help you grow and learn mathematics?
My question is, what does that matter?
So, notice 3, 7, right? And negative 3, 7, right? How that x was multiplied by a negative 1. Anytime you multiply by a negative 1, right, that's creating a reflection. And I mentioned it yesterday, and hopefully you paid attention to this. We have an understanding check tomorrow. You're going to have to tell me the operations that go with that transformation. So if you have a reflection, yeah, Joey, it's been a week and a half that we've been studying this.
At least I remember there was an understanding check tomorrow.
So, if there's a reflection, what mathematical operation goes with that? Multiplication by a negative, right? If it's over the x or y axis, you're multiplying by a negative 1. If you're translating, what operation goes with that? That's addition and subtraction. And then when we're rotating, right, the x and the y switch, right? So we want to pay attention to those details. And so like those x and y's didn't even switch there. This point, to get this point, what had to happen? That'd be a reflection over the x-axis, right? Notice that's the point 3, negative 7, again, multiplying by a negative. So,
That's what I got.
So, but notice, we need to pay attention and be careful. So, how are we supposed to get this 180-degree rotation? There's two major ways. Okay, now if I go counterclockwise 90 degrees, right, that would go over here, and the X and Y would switch, so 1, 2, 3, 4, 5, 6, 7, and then it'd be up to go into this quadrant, right?
But the one that be basically 270 clockwise.
So remember, if it's 90 degrees counterclockwise, that's the same as 270 clockwise, so is that 180?
Oh, no.
No, so what can I do from here? Okay, let's talk about it. What did you do? You what? Oh, for the 180? Well, that's what we're about to talk about. Okay. So, hey, what can I do from here after I do that 90-degree rotation? Another 90-degree rotation, right? So what's going to happen to X and Y? It's going to flip, which notice that means it's going to switch back to what it was, right? And so now it's going to be into here, but it's going to be 3 to the left, and it's going to go down 7 to here. Okay? And so notice when it's 180 degrees, what can we do to the X and Y? Notice it switched back, but the X and Y changed what? To negatives, or they just changed signs, right? Because if there's already a negative, it would become positive, right? So what I would point out is you can easily just do a 90-degree rotation a couple times, and that'll always work. Maddie found, and there are these rules that you can memorize, but the more rules you memorize, the easier it is to forget things. Understanding that each 90-degree rotation just switches the X and the Y, and I just pay attention to the quadrant, it seems like a lot at first, but it works every time, right? So yeah, the rules that you found will work, right? It's just changing the signs. It's just the more rules you find and create them, it's a lot more to remember, okay? But yeah, I could have just switched the X and Y values. Or, sorry, change the sign for the X and Y values. That would have worked as well here, okay? Now, questions, comments before we continue?
No, sir.
Cool, alright, so here's where we are right now, coming back to this. Notice, number 11, we are rotating triangle XYZ how much?
180.
180 degrees this time, right? So, I want you to go to your vertical surfaces, and I'll assign vertical surfaces in a second.
What?
Guys, the TV, the whiteboard, the chalkboard, those are all vertical surfaces. Okay, so who has not worked on the TV yet? I'll say, I've used it multiple times. So y'all used it yesterday, right?
Oh, I worked on TV, I'm sure.
Okay, so I'm going to let group 2 go to the TV today. We'll do TV, so it's these two groups that haven't used the TV yet. Okay, so group 2 will be at the TV today. Who has not used the chalkboard at all? Okay. So group 5, y'all can use the
No,
chalkboard
I did
today.
not use that one.
That's the only chalkboard there is.
That's what I'm saying, I never went
Okay,
over it.
so group 5 will be at the chalkboard. Does any other group want to use the chalkboard? Nobody? Alright, group 1, you're going to the chalkboard, and groups 7 and 3 and 4, y'all will be at the whiteboards. Make sense? So you go to any whiteboard you want. Let's work on number 11. What I will point out, hold on. Sorry, I should have said this earlier. In order to complete number 11, what do you need to do first? Don't you need to do that rotation, right? Get your image. And you need that on your sheet of paper. Answer the questions on the board. Alright, so let's move.
Oh, yeah.
Yes. Yeah, but it's really easy to recognize that you're switching the X and the Y. You can say it's in different quadrants and to figure out the positive, right? Okay.
Come on, dude.
Yeah, group 1's at the chalkboard. Guys, if you're at the chalkboard, you're going to have to erase it. Come on.
Alright, since I.
Wait, hold on. We don't need to compass measurement.
I'll do the rotation.
But we just talked about 180 degree rotation. What did we say was the
I need something. I wrote it down.
Okay. Remember, what happens every 90 degrees?
And then
You can erase that, yes, Maddie. Okay, so the x and the y split. So the left is y right now. It's currently -1,3. So if it's 90 degrees, it's going to switch to become 3 and, well, but pay attention to the quadrant it's in.
Brad, you backed up my first step.
In this quadrant, is x over
it's
there.
a line.
Is y positive or negative? It's gonna be 3, right? Why are you confused?
Still gooch my boy.
Why is not? Why is over here?
Bro, camera. That's what I said. That's what I said.
That's why I said -1 times the left. One. Now that's a 90 degree rotation. I still need Hold on a second, Jaden. I know I specifically did not put you at Thomas's group, and Wesley,
You did.
did I?
Yes.
And then put him up here. No, you're right. I like Wesley. What group are you in then? So y'all are both splitting on that board? Okay. Let's get to work then. Oh, no, I don't want to say that. Never mind. Maybe y'all, it's like, have we done our rotation yet? Okay. Does everyone have the rotation down on the piece of paper? Because it's going to be hard to collaborate if we don't all have our rotations down. I would check your rotation again. Does that look congruent? No. Jade, go to your group. Jade, do not talk to them again. You're not talking about math whatsoever. Sure. So what's giving us issues? By the way, whose is that? So what's giving us trouble with this rotation? So one, most of it would, but what I would point out is 180, isn't that the same thing as 90 plus 90? So could you do 2 90-degree rotations? But if it's 90 degrees, that's what we just talked about. It's going to create that right angle, right? Are you all in the same group? Then separate. Keep mumbling, because you're not doing what you're supposed to do. Keep mumbling. Look, you see how this is up 3 to the left 1? So then, to be perpendicular to 3 to the left 1, to be perpendicular it needs to be opposite and reciprocal. So it needs to go to the, no, it needs to go up to the right 3. See how that's the 23, 1? The x and the y switched, right? And it had to be in this quadrant because it was 90 degrees clockwise. Now we need to do that 90-degree rotation again. So what's going to happen to the x and the y? They're going to switch again, and then, but that would go backwards. We need to keep it going. When you go into this quadrant, so it'd be to the right 1 and down. That would be y double prime.
Oh yeah, I see that.
That's what they're having.
Okay.
Yeah, so
You ain't being nuts.
because this was x prime, y prime, z prime, so this is double prime. Does that make sense?
Oh, okay.
Are you?
Okay, I got you, right? First one. Yeah. Ryan's.
Okay, really quick. What is that? Is that how we write slow? Hey guys. I want y'all to leave those.
Alright, what show me? Wait, down.
Aiden says no, why not? They're one of those, but like, they look like that even to every set. Okay, think about that line continuing versus this line continuing. Do they ever intersect?
I didn't even flip, bro.
We got Wi-Fi.
Look at this, so YZ right here. Says right 7, right? -1,7. So when I look at Y prime, Z prime, you say 1, is that because you went up 1? Okay, but then notice you go which direction to the left 7, so the 7 should have been, are those opposites or reciprocals? Look at that. That's a negative, right? And that's a negative. So are they opposite? They're both negative, are they opposite? Are those reciprocals? They are the same. Because are we all four talking? It's like, it looks like Nathan's working, but it looks like y'all are saying back there. And I appreciate that Nathan's working. That's not his active collaboration sport. It's not going to be great though, because we're not actively collaborating together.
What? Gotta make sure it's extra sharp.
Let's say 60 more seconds to get our slopes and our statements about congruence up there. That's not a... If we say here, after one
I just told you.
right? So that's why two combinations switch again. So it went to 3, 1. The X and Y switch again, so 1, and it's got to be this one, which is there is Y double prime. That Z, notice, is that Z right now on the X axis? Is that how's it in that maybe we actually collaborating. It doesn't look like we are. Where are y'all's sheets of paper? Why do we not check with each other to make sure our rotations are correct before we start working? These here. Because 90 here. That's 5 and 2. Oh, we got it. 5, switch it back to 5, 2, 5, and 2.
That is one.
4, 5, it switches to 5, 4.
If you're looking for a pencil that's not just
Back to 5. You draw it better with the... 30 seconds! Five, 4, 3, 2, 1. Head back to your desk. Alright. I need eyes up here, and I need to talk about a couple of things. I need y'all to pay attention to this. I want y'all to look at this detail. First off, the teal triangle that I have drawn up here, this is after what rotation? 90 degrees. Notice the x and the y values have switched. Remember, I've only done 90 for it now. The x and the y switched. Remember, this was -1, 3. You got actually write out the points, guys, because then when you write the switch, it's going to be a 3 and a 1, and then just look at what quadrant it's in to figure out if it's positive or negative. Because if it's in quadrant 1, both x and y are positive. That's it. Okay? Notice this is literally what we did for number 10. Could you have drawn that rotated triangle and then done the next 90 very easily?
No. Yeah.
What's 90 plus 90? 180. So to do a 180 degree rotation, you can do 90 plus 90. That's it. Now I'm going to show you something else in a second to hopefully make it easier for some people. But notice if this is 3, 1, it's going to switch. It's going to switch back, right? To give me a 1 and a 3. If it's in quadrant 4, is x positive or negative in quadrant 4? Positive. Is y positive or negative in quadrant 4?
Negative.
It's going down, right? So it is negative. So this point would be 1, -3. There's y double prime. Notice that's the second image, which is why they have double primes up here if you hadn't paid attention to that. Now, when I look at z prime, right now that is 2, -5. I rotate another 90 degrees. What do I get?
-5, -2.
Or just in general, right? I get a 5 and a 2. And in quadrant 3, is x positive or negative? Negative. Is y positive or negative?
Negative.
Notice that's all you have to do is you know your x and y are going to switch, and then look at the quadrant to determine what's positive and what's negative. Yes, Emily?
So when you're doing it, the slopes are the opposite to the reciprocals, and then the points are the signs that
One of the signs will change to get the opposite, right? The only way that we get that opposite is if one of the signs change. And there's a way to memorize it, like there is. But instead of just memorizing it, it's easier to look at the quadrant and figure out if it's positive or negative based on the quadrant. Like notice here, x was positive, y was negative. But over here, they're both negative, right? One of them had to change signs to be able to get opposites and reciprocals. Does that make sense? Okay. And so there's my z double prime. And then x prime was 5, 4. I rotate it, so x and y are going to switch for 4, 5. And what quadrant is it going to go into? 3. Right? It was in 4, it comes into 3, so x and y are both negative. So -4, -5. What does it look might be true about all three of those triangles? They're congruent, which should make sense. Okay, so I'm going to erase the prime in here so that we just have the double prime. So we can focus on it. Now, I need y'all to be careful because I see students do this all the time. Not going to reveal which group it was, but does anyone see something that we might need to correct about this? That looks like coordinates, not a slope, right? How do we calculate slope?
Y was like right.
Be careful, remember, y equals mx plus b is the equation of a line. We want rise divided by run.
Please stop saying that.
Right?
Hey, it's okay. Be nice to yourself, Joey. I believe this was 2 divided by 5, right? 2/5. Slope of xy, we already did that one earlier, it's 2/5. If you look at number 10, was it 2/5? Okay. Slope of yz was -1/7. Slope of xz,
-3.
-3 divided by 2. So now look at those double primes. X double prime, Y double prime, what's the slope? Oh, I
Yeah, you,
mislabeled something. No, I didn't. That's right. Here. What's that slope?
2 divided by 5.
2 divided by 5 again, right? Up 2 to the right 5. Y double prime, Z double prime.
Negative 1 divided by 7.
Negative 1 divided by 7. And X double prime, Z double prime.
Negative 3 divided by 2.
And so I want y'all to notice, after a 180 degree rotation, are they still perpendicular?
Yes.
Look at those slopes. The slopes are the,
Exact same.
so they're not perpendicular, they are
Congruent.
slopes. What does slope determine? If it's perpendicular or parallel. Remember, if the slopes are the same, they are parallel to each other. They'll never intersect. Jamie, you had a question?
I was confused about, the slope of X, Y, because, don't you have to go left 5 and down 2 to get to, from X to Y?
Were you looking at the one that was here?
I'm just looking at X, Y, not,
X, Y is here, right?
yes.
It's up 2 to the right 5. Or, you can look at it as down 2 and to the left 5. But if I take negative 2 divided by negative 5, you know what I get? Positive 2/5. Same as this. So it doesn't matter which direction you go, but you gotta do rise and divide it by run. Right? Notice how that's on the opposite side of the x-axis, or y-axis? That needs to be over there. Okay, so that's those done. So this is just a fill in the blank. I'm not saying that we're going to get this perfect. I want you to go back to your boards and write out what you think the answers are for 12A, 12B, so on and so forth. Think about what we know, what happens when you rotate and reflect and translate images. What do you know about those angle measures? What do you know about those sides? Come up with answers. We don't spray the board, we spray the cloth. Now, you already have plenty of space to answer your questions. I wouldn't even erase anything. Group 5, why are 3 of us still seated? Come on now.
Sorry.
Or group 4, not group 5, sorry. Group 5 doing well. Jaden, what's your group, my man?
Never had to write a word.
And while you're waiting on that section for the drawing, go ahead and start answering some on this lower section that's already on.
We forgot. Everybody, we forgot.
That's, thank you, thank you. Really quickly, hey, listen, when they talk about corresponding, if you were to take point X and you were to rotate it, which point would correspond to X?
Y.
X.
X prime, right? Remember, right, when we say corresponding, we mean the same ones. So if you have side length XZ and you rotate it or reflect it or translate it, which side length would correspond, or side would correspond to XZ? X prime, Z prime. So when they talk about corresponding, they're talking about the pre-image and the image side lengths, or the pre-image and the image angle measures. Does that make sense? Okay, so the corresponding would be the pre-image and the image that are the same. Right, so XZ and X prime, Z prime. Angle X and angle X prime. Things like that. Alright, let's answer those questions.
look me up for Thing is, your hair can be crazy. It's not long enough.
Oh, wait, there.
Wait, you, hold on. Oh, I got you. Do it as two, it's still number 13, but do it as two different sections. Right, because you're doing that first blank, and then the next two blanks. So leave that answer there, and then do your next answers below. Yeah, do it as like a 13A and B. It should have had an A and B already. That's the best way to say it.
I know it's
So let's talk about 12A. So we have seen sometimes where sides are parallel and sometimes they are perpendicular, right? There's only one plane, so it can't fit both.
Look at it.
Yeah, close court door. I'm gonna tell you again, what have we noticed about the sides? What should be true? But not every time. We did 180 through it, it was parallel. What is one thing that's... Well, but look, let me see this. Well, you gotta draw it. Everybody draw all the time. Notice these corresponding sides are parallel. Whereas these corresponding sides are perpendicular. But look again, there's one thing that's true.
I know my own corresponding side like.
Bro, say cheese. Are they all congruent? Corresponding sides are always congruent. Alright, 2 more minutes to finish answering these questions. We'll discuss the ones. Hey, by the way, guys, don't write the whole thing out. Just write out what goes in the blank. You're gonna waste too much time on that. Okay.
Oh my god.
It looks like
The angles are parallel.
it looks like Seth has an idea that's okay, but what did Debbie write up there? Are the corresponding sides of the triangle congruent? After the station? So did you call me up? The answer is no. She told them that answer. No, you don't need to ask talk about it. Yes, you can write the answer, but I need all this to talk about it. Okay. Nathan really had no clue we were talking about it. I need us to ask something about it.
Hey, that's us.
If you're going to say those are reserved, what does that mean the triangles are? Remember, come on, what's the mathematical word? The corresponding angles and sides are congruent, and the triangles are congruent. Right, it's talking about the side lengths, and the angles are congruent, and the triangles themselves are. Does that make sense? The triangles are congruent. Hey, Maddie, if you're gonna wash it off, wait till it dries for you right there. I would just, that's how my class always written on the public triangles.
So we,
right, there you go. Alright, sorry, we got a little carried away. 60 more seconds before we come back together. Get as many answers up there as possible.
your marker is dying.
You're dying. No. Technically, everyone's dying. You know.
I need a marker.
There's a whole lot of
And then
Sit at the. Sit at the. In the middle.
Go get off.
I mean, if you can make Wednesday would be better, because I'm not, I need to get home and tell them why.
Why is he still on there right on the board?
Let's do tomorrow. All right, let's move back to our groups and let's talk about it.
What would you sit on the bench?
Our desk, yes. Hey. Don't know what. Thank you. Thank you.
Come on, sit, Brad.
Thank you. Thank you. All right, so let's talk about some. Okay, so I've seen two different sets of answers when it comes to A and B on number 12. I've seen, and some people changed it. Some people are saying that those corresponding sides are congruent, but I also see the corresponding sides are parallel and perpendicular over there. If you have a rotation, right, are the corresponding sides always parallel? When are the corresponding sides parallel for a rotation?
Period.
Right, but which rotations give us that same slope?
Translation.
180 degree rotation. Yes, translations give us parallel slope or parallel line segments, but I'm talking about a rotation right now. Only the 180 degree rotation gives parallel line segments. Right? Jaden, you focus in?
No.
Thomas. What's your name, Jaden? Then don't talk for him. I need both of y'all to get the hood off. Come on. Like, y'all act like you haven't been at Hillcrest High School for...
I ain't saying it. I ain't saying it.
No, you're not allowed to have a hat either. You know this. If you're not allowed to have something on your head, you're not allowed to have something on your head. Like, it's not complicated. Respect the rules. Okay. When are the sides perpendicular? When the rotation is... When the rotation is 90 degrees. Remember, we get the opposite and reciprocal slopes when it's a 90 degree rotation. Right? Which is why when a 90 degrees or 270, you'll get that happening. But I would also point this out, and I need y'all to look at this. Corresponding angles of rotated triangles, can angles be perpendicular?
No.
The line segments can be perpendicular, creating what angle? What angle? Because it's not a triangle. Right angle, a 90 degree angle, right? So we need to look at this again. Let's look at what some of the other people put, right? Congruent. Are the corresponding sides of a rotated triangle congruent?
Yeah.
If you look at your rotated triangles on there, XZ and X prime Z prime, do they look to be the same length?
Yeah.
Yes. YZ and Y prime Z prime, do they look to be the same length? Yes. If you were to use that distance formula, would you get the same length?
Yeah.
Yes. So the corresponding sides are congruent. The corresponding angles are congruent. And so, notice if you looked at 13, it would have helped you with 12 A and B. So if a triangle is rotated about a point through X degrees, that just means any angle. We're only looking at 90, but this just means any angle, right? The corresponding angles and the corresponding sides of the pre-image and the image are... Literally says it right here. I haven't got to the end. Guys, look. The corresponding angles and corresponding sides are congruent. And the triangles, so those elements are preserved. But what does it mean that the triangles are? The side lengths are preserved, the angles are preserved, the areas are preserved, so the triangles themselves are congruent.
Wow, that's a lot of congruence.
That's a lot of congruence. But that's kind of the point, is that if we do a rotation, the triangles are congruent.
Yeah.
Therefore, a rotation is what? Quite few of us put it up here.
Rigid transformation.
Rigid transformation
Isometry.
or an isometry. Or an isometry. Now, the last detail I totally understand us having trouble with, but you remember how you all were talking about preserved earlier? That's what they're looking for here. We also say the rotation is distance preserving. And so I totally understand it's not getting this one. But what does that mean when we say distance preserving? We're saying that the side lengths are the same. Because it's a rigid transformation, because it's an isometry, we have a distance preserving transformation.
So where's the distance?
Huh?
Like in distance preserving, what's the point of it? Like off the top?
Okay, I'll come back to that in a second. I'll need to go back to a previous one though. Okay? Not only is it distance preserving, that means the lengths are preserved. What else was preserved? The areas as well, yes. But the area depends on the distances. So angle preserving. Remember we said earlier, right, and that's where Emily got the area, we've said this whole time that the side lengths are preserved, the angles are preserved, and the area is preserved. So you say distance, remember distance is just the length of those sides. Does that answer your question?
Mm-hmm.
So we've just always said side length, but that's the distance. Okay? I want to point this out. All of those statements are also true for what other transformations?
Translation.
Translations
Reflection.
and reflections, right? Well, and we already have rotations here, right? All of these statements about the triangles and the sides and the angles being congruent and about it being a rigid transformation and distance preserving and angle preserving, all of those are true for reflections and rotations as well, or reflections and translations as well. That's the whole point, is that the pre-image and the image are congruent, right? The whole point is that the pre-image and the image are congruent. One detail I do want to point out and remind you of here. So I'm going to call this triangle ABC. And you will want to make a note of this on your paper. Obviously, I'm not a great artist. I'm going to just say that these are congruent. So, oh, that's hideous. Sorry. I'm just estimating here. So A prime, B prime, and C prime are there. First off, what transformation do you think I applied?
Translation.
Looks like a translation. Literally, like everything looks to be the same. It's just in a different spot, right?
Right.
That's a translation, okay? And so that's my translation. Let's say that I do this. And it's not perfect, but anyone want to guess what transformation I just applied here?
Reflection.
That would be a reflection, right? Okay. And then I'm going to do one more. Put Anybody know what I did here? That was a rotation around this point, okay? Have we drawn this out? since I told you that I would recommend doing that. Okay, I know it's not perfect, but I do want you to see this really quickly. Okay. And so do you notice, like the translation, I drew the arrow down. For the reflection, I drew that line of reflection. For the rotation, I drew the point of rotation. You gotta have those things. By the way, I will point out, does anyone know what degree rotation I did here?
90.
180.
If it went from here to here, that's 180, right?
Uh,
You see how it went all the way around there? Right, so 180. I sent it. There's no way for you to finish it right now in class. Let's do it tomorrow. There's no way to do it in 30 minutes.
20 feet.
All right. So here's what I want to point out, because this is the last thing that is important. If I start here at A, and I go, let's go counterclockwise, what's next? C, then B, then A. If I start here at A and I go clockwise, what do I get to? C, and then A. If I start here at A and I rotate clockwise, I go to C, then, and then A. But if I start here at A and I rotate clockwise, what do I go to? Notice how when you do a reflection, right, it changes the order that we get to our side lengths in. So when we talk about translations and rotations, we would say that these are also orientation preserving. I mentioned this when we did the first exploration, but these are orientation preserving, meaning that when I do go through it clockwise or counterclockwise, the order is the same. Orientation preserving, meaning that the order of your vertices is the same. So does anyone know what we'd call it for a reflection, since it's not preserving? Talked about it as in terms of uno last time.
Oh, reverse.
Right.
you're gonna reverse card.
Yes, but it is a orientation
Reverse.
reversing. So do not forget that translations and rotations, they are orientation preserving, right? We wrote this down, we drew out our images, we read all that information about orientation reversing and preserving. No, you have written no words down, that's impossible. So orientation preserving, the order of vertices is the same. Orientation reversing means that the order of vertices is the opposite, right? It's in the opposite order, right? It's reversing. Okay. Now, we're not studying this right now, but I want to show you number 14 quickly, and hold on to your packet because we will come back to look at these later. This whole time we've been talking about rigid transformations and isometries, right? And they have been distance preserving, they've been angle preserving. But does anyone know the one transformation we have not studied at all yet?
Dilation.
Dilations. Okay? This is how a dilation works. We have a point of dilation, and I'm just going to take this.
Man, you have a lot of green markers.
Yep, I don't like those lime green ones. They make me angry. Okay, right here, looking from A to Y, it is 5 inches. Okay? So if I wanted to triple that, how far would I go?
15.
15 inches. Alright, so I'm going to go to 15. There it is. There is Y prime.